Hi YouTube, welcome to my YouTube channel Easy Concepts. This video is about a core concept in computer programming, that is upcasting and downcasting. Regardless of which programming language you use, you need to know these concepts. Especially if you're a recent computer science or an IT graduate, these concepts may haunt you in interviews. So why not just learn and get hold of it? So let us begin talking about upcasting and downcasting with its definition. What is upcasting? Upcasting converts an object of a specialized type to a general type. That is, when you are doing upcasting, you are actually casting it to its supertype. Now, if you look at the right hand side, we have a class called bank account. Class has a method called generate account number. Now, these are all hypothetical methods. Please don't go by the literal meaning of it. This is just for the explanation purpose. Okay, so this class bank account has a method called generate account number, which prints just a string called bank. Now, these three classes, saving account, checking account, and lottery account, are all derived from bank account class. That is, these three classes are the subtype or child of bank account class. So they have all the functionalities of bank account class plus some additional specialization. Now, if you see for saving account and for checking account, all of them have the method called generate account number. And it's just that the implementation is different. Here they are printing saving for saving account, checking for checking account, and lottery for lottery account. Apart from having the functionality of a parent class, they have an additional specialization. Like if you look for the saving account class, it can perform an additional duty of fund transfer. Similarly, checking account can do unlimited transaction and lottery account can give rewards point. When you are doing upcasting, you are actually casting your subtype to supertype. You are making your specialized object a general one. Upcasting occurs with loss of some specialization. We'll see that in detail with an example. If you see downcasting, downcasting converts an object from a general type to specialized type. The red arrow here shows downcasting and it is going downward. That is, it is going down the line of inheritance. So when you go down, you are casting to the subtype. Casting never fails, and that is because you're moving up in the line of inheritance. See this green arrow, it is going up because you're going from more specialized to a general type, so it never fails. Derived class or subtype just loses specialized function. Actually, there's no loss of specialized function, it's just that you can no longer use it. Let's take a logical example of a doctor and a surgeon. A doctor can prescribe medicine, while a surgeon is a doctor. Notice is a relation. Surgeon is a doctor. So a surgeon can prescribe medicine and a surgeon can also perform surgeries. For example, a surgeon can cut open an organ depending upon his or her specialization. This is because upcasting seems natural. If you see, a surgeon can act as a doctor, but a doctor cannot act as a surgeon. It is because you're doing downcasting. You're asking something that is of a general type to act as a specialized type, and specialization cannot be offered because they do not have that specialization. So, downcasting is usually discouraged and upcasting is allowed because you are moving up the line of inheritance, and in downcasting you are moving down the line of inheritance. Finally, when you are converting any specialized class, check-in, saving, or lottery account type into bank account type, it is an easy thing and it never fails. Now let's see the right hand side. Here we have a bank account class whose objects are B1 and BA2. In the next line, we have a lottery account objects LA1 and LA2. In the first example, we are trying to do upcasting, which is allowed. So BA1 is a bank account object. When we say BA1 is a bank account object, that means BA1 is of type bank account. And it is also pointing to a bank account object. But when we write like this in example 1, BA1 is no longer pointing to a bank account object. Now it is pointing to LA2. LA2, if you see here, LA2 is a lottery account object. So BA1 is still of type bank account, but it is pointing to or it is referring to a lottery account object. So the type of B1 decides what methods you have access to, and the reference decides which method implementation you can follow. Now, if you look at BA1 is equal to LA2, because it is of type bank account, it has no access to lottery account methods. That is, if you see here, this general account number is of bank account type, so it can access it. But even though it is pointing towards lottery account object, but because it is of type bank account, it has no access to rewards point because it has become general from being specialized type. So if you try to access BA.rewards point, you will get an error because you cannot access rewards point. That's because the implementation of lottery account object prints lottery. Now, if you look at the example 2, here LA1 is equal to BA2. That is, you're making an object of type lottery account points towards bank account object. This is just like asking a doctor to perform surgery. But because a doctor is not of specialized type, a doctor cannot perform a surgery. Here, you're moving down the line of inheritance. You are trying to do downcasting, that is bank account. Here, bank account to become a specialized type, that is LA1, which is of a lottery account type. How can BA2 be LA1? Because it cannot provide all the specialization LA1 needs. So LA1 cannot refer to BA2. So the compiler gives compile time error. In the third example, what you're trying to do is you are trying to fool the compiler into thinking that it is of a lottery account type. If you see, BA2 is a bank account object. To make a lottery account object point to a bank account object, but this cannot happen because LA1 is of type lottery account and it cannot refer to anything that is down in the line of inheritance. Example 3 is essentially same as example 2. The only difference is that you are trying to forcibly typecast a bank account object into a lottery account object. Notice the typecasting done here. We have typecast bank account object into a lottery account type. This fools the compiler into thinking that BA2, a bank account object, is actually of a lottery account type, because of which it doesn't causes a compile time error and the program compiles successfully. However, at runtime, the JVM tries to find out what BA2 refers to. If you notice, BA2 refers to a bank account object. This type of downcasting will cause runtime error, and if you're using Java, it will cause class cast exception. Moving on to example 4, our last example. Here, we are making a variable of type lottery account refer an object of bank account type. And we are also forcibly typecasting it into a lottery account type. But why does it work, unlike our third example? Why it gives no runtime error? This is because if you see this BA1, which is a bank account object, was actually in example 1 was upcasted and it was referring to a lottery account object. So later herein at runtime, when the JVM tries to find what it refers to, it actually sees that it refers to the right thing. It refers to lottery account object and it is also typecast into the right type, that is lottery account. So this downcasting works because BA1, which is no longer of type bank account, instead it is of type lottery account, is pointing to a lottery account object, and that object can provide all the information a lottery account type object needs. This is the reason this downcasting is allowed. Because this BA1 object is downcasted to a lottery account type and it is also pointing to a lottery account object, we can write la1.rewardsPoint and it will work. That's because it is being downcasted to a specialized type. So now it has the access to rewards point method. Upcasting and downcasting is quite tricky subject. An important thing to note here is that the typecast of an object decides what all methods it has an access to, and its reference decides which class method implementation to follow. To verify this, let's go to the first example. You see, BA1 is of bank account type, so it only has access to generate account number method. It cannot access rewards point. However, BA1 points to a lottery account object, so it will follow implementation of this method, that is a lottery account method, even though the generate account number is in bank account class. That's because type decides what all method access it has. However, the implementation is decided by what object it is referring to. Here it is referring to a lottery account object. So when we do BA.generate account number, we will see that we'll get output string lottery. So this was about upcasting and downcasting. I hope you enjoyed my tutorial. Thanks for watching Easy Concepts. So this was about upcasting and downcasting. I hope you enjoyed my tutorial.